welcome. Thanks for coming. My name is Matthew, and I am one of the web developers over at Dayton Metro Library. And I have no idea how to close out this presentation. Perfect. And today we're going to be talking about Flutter. I'm going to go, ooh, ah. Anyway, my name is Matthew, and I actually, I'm one of the developers there. And a while back, we were having an issue. We were subcontracting with a third-party company for our app. And it was a substandard user experience. Patrons complained about it, staff complained about it, all kinds of people complained about the app. And so we started doing a survey of the market and just tested out other companies that specialized in the niche that we needed. And we weren't really satisfied with what anyone had to offer us. And so what we eventually I approached my boss and said, will you give me a crack at writing it? And he said yes, which was awesome. So then I started doing research on frameworks, and I was looking for something that would allow me to write one code base that would compile to iOS and Android, because I'm a single developer. And I just didn't have the time, because we were on a tight time commitment, to write two code bases. I couldn't write a Java app for Android and a Swift app for iOS. It just wasn't going to work for us. So I did a lot of research, and I found stuff like React Native, and eventually I settled on Flutter. And Flutter is amazing. You guys are going to have your minds blown tonight. I briefly made my living as a children's birthday party magician. A lot of people don't know that. And this feels like a magic trick every time I do it. Like seriously, the fact that I can write one set of code and compile everything is amazing. So we're going to write an app together today, and it's going to be one code base, and we're going to have an iPhone app, an Android app, and then lastly, we're going to turn it into a web app. All one code base. Let's get started. So, let's start with what is Flutter. Well, Flutter is a somewhat new framework from Google. I say new-ish. It's been around for a few years, but it just hit its 1.0 release in December 2018. So it's only really been stable for production usage for roughly about a year. So it's still new. It doesn't have the buzz that things like React and React Native have, but it's definitely growing rapidly. And like I said before, it allows you to create apps for multiple platforms in a single code base. I mentioned Android, iOS, and web. The other thing that they're working on right now, and it's in alpha right now, is desktop apps. So I'm sure everyone's familiar with Electron. Yeah, Electron. It's similar to that, but you'll be able to just use that same code base and compile a desktop app as well. So I know for those of us who have, are a little bit older, the promise of write once, run everywhere has been around since the early days of Java, and it's never really been fulfilled. Like, honestly, it's write once, hope everywhere. And my experience of Flutter is that it's not been that. My experience of Flutter is that it literally does what it says it will do, and it will compile out, and I've had very few platform-specific issues. And that's really what makes this platform this framework, so phenomenal. So who's using Flutter? Well, Google, obviously, because Google are the people that created it. Alibaba, Tencent, Abbey Road Studios, and the prestigious Dayton Metro Library. Yes. I put myself on there. I have no apologies. Sorry, not sorry. I'm proud of that app that I wrote. You should all pull out your phones right now and download the Dayton Metro Library app. It would increase our install numbers, which would be fantastic. If you don't have a library card, we can fix that problem for you. So, and there's actually hundreds and hundreds and hundreds of apps out right now that run on Flutter. There's a website called itsallwidgets.com, and you'll understand that name here in a little bit. It's called itsallwidgets.com, and you can view the hundreds, I think it's thousands at this point, of apps that have been written and deployed using the Flutter framework. So, what makes Flutter different from React Native or is it Xamarin Forms? I don't know how to pronounce it. Xamarin, thank you. Xamarin Forms or whatever. What separates Flutter from those other platforms that kind of do the same thing? They promise to have a single code base that you can compile out and do multi-platform types of things. Well, the first thing that makes Flutter special is that it uses Dart exclusively. So you don't have to worry about knowing multiple languages. Everything is done in one single language, which is Dart. There's no HTML, there's no CSS, there's no JSX, there's no JavaScript, none of that. All you have is Dart. And for some people, that's actually a drawback. I'm hoping to sell you on the point that it's an advantage by the end of this evening. That's one of my goals. Number two is that Flutter re-renders everything. So does anyone in here have experience with React Native? A little bit? Okay. React Native uses the native UI elements that are baked into the operating system. And that's all well and good, but the problem with that is that you can't necessarily guarantee consistency across platforms. So if one person's running Android 5, and another person's got Android 10, and another person's got Android 8, the UI is different on all of those. So you don't actually know what the app is going to look like. With Flutter, because it re-renders absolutely everything, you can guarantee a level of consistency that you just can't get out of React Native, unless you do a whole lot of additional coding. And that was one of the benefits that we came to with the library, is when I started doing multi-platform testing, I was amazed that literally it looked the same everywhere. Like there's teeny tiny differences because Flutter tries to adapt to the platform that it's on, but as a whole, it's the same. And my designer really loves that because she's one of those people that wants everything to move 2 pixels to the right. You've all worked with that designer, right? And she's amazing, don't get me wrong, she's absolutely awesome. But she loves that consistency. And actually, Flutter comes with a ton of pre-made widgets. Now, I know that that's probably a dirty word to say, ooh, pre-made, it's like Legos, put it together, make my little Lego castle. The reality is, the level of customization that you have over those widgets gives you a ton of flexibility and power. And actually, I'm going to pause the presentation. Well, no, I'm not going to yet. I'll get to that in a second. So I just want to cover a few basic fundamentals of Flutter and Dart before we get started, because most of this evening is going to be code, and I've got a lot to cover in about 40 minutes to do it, so I apologize if I move a little bit quickly. But I don't want you to get confused, and so I know that some of you, maybe JavaScript is probably the only language you've worked in, because you can be a full-stack JavaScript developer now. So I'm just going to go over a few things that are specific to Dart, and if you're rolling your eyes, just be patient. There's probably someone who will benefit from this. So first of all, Dart looks a lot like JavaScript if JavaScript wasn't on crack. Like, I don't need to insult anybody here. But even those of you who are JavaScript developers, you know it looks like it's on crack, you know? Jokes aside, JavaScript's a great language. It really is, and it's very flexible. But Dart does some things that I think are very smart. Number one, it offers classical inheritance as opposed to prototypal inheritance. So I know that that's a preferential thing, but I personally love like having classes and true like object-oriented programming and inheritance and things like that. It does offer class composition. Those are done via mixins. And it does not offer interfaces, which is a negative. But it does offer abstract classes. So that's beneficial. The great thing about Dart is if you know JavaScript or if you know any other language, you can learn Dart in an afternoon. In fact, by the time we're done tonight, most of you will probably be like, you know what? I don't need to read a book on Dart. I know enough of what's going on that I can probably program in Dart. It's that straightforward. Yes?
How similar is Dart to Kotlin?
I don't know. I've not used Kotlin, to be completely honest. So I know what Kotlin is, just I haven't touched it, to be completely honest. So, yeah. So a few features that are specific to Dart. Number one, classes can have multiple named constructors. That's not necessarily true in all languages. That's really valuable. So if you've got a model, you can have one constructor for building out the JSON and another constructor for building out a database. You don't have to declare your variables with a type, but it's better if you do. So all three of these options here, var, int, and final, well, I'll get to final in a second. Var and int, both of those are legitimate. So if you want to go willy-nilly JavaScript style and not put a type on your variable, Dart don't care. Dart won't accept that. Should you do that? No. If I see your Flutter code and you use var, will I strangle you? Absolutely. For a variety of reasons. Number one, you're going to get better performance if you put your typing in, because Dart knows what they expect. And so you're just going to get better performance if you have your typing in there. Hi, welcome. Come on in. You've missed nothing. I'm just gushing about how good Flutter is. And then the second thing is it's just better for debugging. Like, because Dart will get upset and you don't have issues where 1 + 1 = 11. And I'm sure all of us have had 1 + 1 = 11 when working with JavaScript at some point. It just happens. Triple equals. And then methods can have both named and unnamed arguments. So examples of that, if you look at the first function definition at the top, the first argument there is an unnamed argument, and the second two are named arguments. So when we call it, we can either, we put our named value first, and then we call our, we put our unnamed value first, and we put our named values with a colon after it, and that's how we pass that in. And that allows us to have hundreds sometimes of method parameters, and it gives us an easy way of accessing them. And as we get into writing some dark code, you're going to understand why that's so valuable. So just know that that's a thing, that's how it works. You can have either or both, doesn't matter. And then the next fundamental you need to know is that everything in Dart is a widget. I mean, everything in Flutter is a widget. If you see it, it's a widget. If you think it goes into something, it's a widget. The app itself is a widget. You put widgets in your widgets, and inside of those widgets, you stick other widgets. Like, I'm not kidding. By the end of this, you'll realize that the Yoda meme is the most appropriate here than wherever you've ever seen it. Like, Yoda, I heard you like widgets, so I put widgets in your widgets so you could use a widget while using your widgets. I kid you not. That's exactly what we're doing here. And you'll see that when we get into the live coding portion of the evening. So, Flutter comes with hundreds of highly customizable pre-made widgets. The material design widgets are the most popular. Yes?
Is widget synonymous pretty much with component for something like Angular? Or
Yes, if you've worked in Angular or you've worked in, yes,
Okay.
exactly. You can substitute the word component and it's the same thing, absolutely. And if you don't like the pre-made widgets, you can write your own. So real quickly, I'm just going to jump over here real quick. If you do any type of Flutter development, this widget catalog quickly becomes your best friend. So examples here, let's just go to the basics here. Like we've got the app bar widget, which allows you to very quickly lay out an app bar. You've got container widgets, which are basically divs. You know, if you're used to divs on divs on divs, it's containers on containers on containers. And there's just hundreds of them here. And then if you want to write something that looks very native to like iOS, for example, they've got these Cupertino widgets. And like I said before, these are all re-renders of the native widgets. So these are not the native widgets themselves. Flutter is re-rendering it, and that's awesome because it lets you customize and do things that you wouldn't normally be able to do. But whenever you're trying to do something, your first step is coming over here to this doc and just looking through the widgets and going shopping, to be completely honest. And then you basically customize from there. And you'll see how that works here momentarily. All right, coming on. All right, it's live coding time, y'all. The most terrifying part of any presentation is the live coding time. Sorry. I warn you in advance, this is semi-live coding. I didn't want to stand here and fumble the whole time. So what I've done is made snapshots throughout the coding process, and then we're going to talk about them. So basically I made like 29 GitHub branches, and we're just going to cycle through them here. So
it's a cooking show style.
Yes, it's like, in 2 minutes you've got a fully baked app. So, what we're going to do is we're going to build a Yoda Translator app. Any Star Wars fans in here? Anyone like Star Wars? Yeah, anyone stoked about Rise of Skywalker? Anyone got a crush on Harrison Ford like my wife does? All right, perfect. Anyone got a crush on Ray like I do? Okay. We're going to build a Yoda Translator app. So basically what it's going to do is we're going to be able to type in an English sentence, and then it's going to pop back and give us the exact same sentence only in Yodish, which is really fun. It uses an API that I found through rapidapi.com. It's horribly documented, but fortunately it's pretty simple. And I think I'll just go ahead and bring up the API real quick so you guys can see it. This is the API that we're going to use. And as you can see, Yoda API documentation, 1 sentence. Thanks, guys. But fortunately, it's straightforward enough that you can figure out what you're doing. And I'm not going to belabor this point too much because you'll see it once we get into the coding portion. So the first step, if you're creating a Flutter app, is you need to, any React developers in here? Any React developers? You know create React app? Yeah, this is going to look familiar. So let me just enlarge this a little bit. We're going to Flutter create my app. My app. There you go. Perfect. And then basically what this does is it just generates a scaffolding for you. And, oh look, we're all done. Lovely. And,
You have the NPM
Flutter for the CLI.
No, it doesn't use NPM. So basically, just as a heads up, it takes about 4 hours to get the development environment set up on here.
So you've already got the CLI set up.
Yes.
So
Yeah. I didn't set up the code environment just because we'd be here for like a mini series of 3 weeks if I did that. So
I'm not going to code with you. Sorry.
Does it have another package management?
It doesn't have automatic package management, but there are plugins, and we're going to talk about how to use plugins a little bit. Yeah, I'm a little bit worried about the Flutter doctor isn't happy with my Android tool chain. We're just going to go on and hope for the best. Okay, so when you generate that, we're actually not going to use that folder. We're going to come over here to the one that I already generated. You have several folders that are automatically generated for you. So we're just going to go down from the top. Android is all the files that you need that are Android specific. So your build.gradle file is going to be in here, and you're going to need that. Any Android developers are familiar with the Gradle and the living Hades that it can cause sometimes. Your build.gradle is in here. Everything Android specific is in that folder. The build folder is where the files that are actually compiled out get put in periodically. The iOS folder is just like the Android folder. Your Xcode project lives in there, and yes, there is an Xcode project that you will need to work with when you go to deploy to install things like app icons and things of that nature. And then the lib folder is where we do the vast majority of our work. That's where our source code goes, and we'll be building most of our source code inside of that. And then we have a test folder. There is built-in unit testing inside of Flutter. You can test everything. We're not going to be demoing that tonight just because for the sake of brevity, I didn't think you guys wanted to see me write unit tests. So when you generate that, it creates a It creates a demo app for you. So we're just going to go ahead and fire up the demo app here. And it's going to go ahead and compile it. And it's going to fire up on the Android emulator that I've got running on another screen here. So bear with me for a second while it does this. And this demo app is really, really simple. Literally all it has is a counter and then a little button on it. And every time you hit that button, it just increments the counter. But it's to give you an idea of basically the way a Flutter app is built. And then this pubspec.yaml file I forgot to mention. That's kind of like if you, any of you familiar with WebPack, where you put in like your dependencies and things like that, pubspec.yaml is where you're going to be taking care of that. Okay, it looks like we're good. And so this is the demo app that you get when you do Flutter Create App. And literally all it does is you hit the button and it increments the counter. Ooh, we are pushing the boundaries of development here. Amazing. Okay, so what I'm going to do is I'm just going to fire up this main.dart file. And there's a few things that I want to point out here. We're not going to do a deep dive into this because it's more fun to write code than it is to read it. So we're just going to quickly do an overview. First thing I want to point out is this material.dart import up here. Remember when I was showing you all those pre-made widgets you could use? Most of them are in that material.dart file. So you have to import the specific libraries that you want to use. And material.dart is going to be pretty much in every Flutter application, every widget, everything that you write. That's going to be at the top of your file. And then we have it's a stateless widget right here. Flutter is not overly opinionated about how state works. You have stateful and stateless widgets. You're very rarely going to see me use a stateful widget. A stateful widget manages its own state, and frankly, there's better ways of managing state. And if you're confused by what I just said, we're going to get to state management here in a little bit. If you're familiar with Redux, Flutter honestly isn't all that different in the way that we're going to use it today. And then we've got our first widget, which is the build widget. And it returns a material app widget. And that's just a whole bunch of scaffolding. All the stuff that you need to build an app, it's going to be in that material app. And then we've got our first named parameter here. Remember, that's why I pointed that out earlier. So it just has a title, a theme, and a whole bunch of other stuff. And you know what, I'm already bored, so we're going to quickly labor at this point. Let's move on. We're going to build the most bare bones app that we possibly can. So I'm going to go ahead and switch GitHub branches here. And what I've done is I've now created a source folder that I'm going to put all of my source code in inside of the lib folder. And the first thing I did is I pulled everything out of main.dart and I threw it into app.dart. And that just is some general housekeeping that I like to do. So every Flutter application has a main function. Those of you who are C programmers will recognize that. And it basically just runs our apps. So that's the last we're going to look at main.dart. It becomes super boring. Inside of app.dart, we have our bare bones. So we've got our app widget. So the app itself is a widget. Remember I said everything's a widget? And it's going to extend stateless widget. So we're going to manage state, not here. And then every stateless widget, and actually every widget in Flutter has a build method. And that build method takes a context, and we'll talk about what that context is in a little bit. And we're going to return that material app scaffolding, and we're going to give it a title. And this debug show check mode banner thing is just so that it gets rid of this weird thing that reminds you you're in testing mode, we don't care. And then for the home page, we're just going to return a text widget that says hello from a galaxy far, far away. And that text, like I said, is another widget. So we've got a widget that's being stuck inside of a widget that is essentially a widget. All right, so that gives us this. Ugly, right? So ugly. We need to do something about this. But that is the smallest, most bare bones Flutter app that you can basically build. And we're going to build everything else on top of this. And wow, I'm done in almost 20 minutes. Okay, so let's go ahead and build our first screen. So let's go to that. Refresh the app here. By the way, in case you didn't notice, there's this cool feature in Flutter. If I hit Shift-R, it automatically refreshes the app, and so I don't have to completely rebuild it from scratch every single time. It makes development so much easier. Okay. So now, in this branch, if we look at the app.dart file, we replace the text widget with the home widget. It looks pretty similar, except for we've got a home widget. Well, that home widget is now a custom widget that I've created. And that widget is actually our first screen. The screen itself is a widget. So I've got a new folder here called screens, and inside of that I've got our home.dart file. And inside of this is some more stuff. So the first thing I'm doing is returning a scaffold, which is going to give us more structure and some more predefined things that we can use and customize. We're adding an app bar widget, and inside that app bar, we're adding a text widget and stylizing that text with a text style widget. Are you guys getting a hint? Do you mean to quit saying widget at this point? I think I'm belaboring the point. And as we go down, we can specify our background color and our body. And inside that, I've defined a screen content. So you're noticing a lot of indenting here. And that is one of the major things that people complain about with Flutter. It's like, man, there's so much indenting and it's so confusing, and you need to use the auto formatter to really make sense of all of it. Well, the answer is, if it gets too gnarly, you need to break your big widget down into sub-widgets. That's just what it comes down to. You know Uncle Bob's saying that every function should have exactly one purpose? Every widget should be broken down to its smallest logical form. And that's what we did here. So for the body, we created a screen content widget, and that's going to have our text inside of it. So now this should look a little bit better. We've got our app bar at the top. We've got our message in the bottom. We've got some basic kind of UI elements here. And then we've got a blank canvas that we can kind of build on. And that's what we got from adding that scaffold widget. So I see some confused faces. Any questions so far? Yep, cool. I'll keep going with that. All right, so one of the big things that people ask me about is like, well, how do you add a menu? And this app doesn't really need a menu, but I'm going to take a 2-minute digression to show you how a menu is made. So I'm just going to jump ahead to my sample menu branch. And refresh. Okay, so inside of my app bar widget, I've created a menu drawer widget. This is a custom widget that I created myself. Where did that menu drawer widget come from? Well, I've created this widgets folder here, and inside of it, I've got menu drawer.dart. So this is a custom widget that I've just created. And inside the menu drawer, I've got a drawer, which is one of Flutter's pre-made widgets. And then I specified some colors. Safe area is basically just to make sure that it doesn't get cut off by the notch that's so popular in modern phones. Ugly. And then inside of that, I've added a couple menu items. And again, I specify that down here. And we've got some basic routing set up as well. So when you click on one of the menu items, you'll be able to go to that specific route. So we've got named routes. So yeah. Do I have the? Yeah, I don't have the routing working yet. So we'll explain that in a second. So basically, what this gives us is this little hamburger icon up here, and you tap it, and now we've got a menu. And it's not working yet because I'm not showing you how to set up routing, but it gives us a menu. And if I wanted this to be on the other side, I could customize that. Like I said, you can customize this to your heart's content. Yeah. So one thing I want to draw attention to is if you look here, we have a whole lot of code in the scaffold here that's going to be repeated if we create another screen. And one of the principles of programming is don't repeat yourself, right? So we're probably going to want to refactor that at some point. And we'll get to that here next. So what I'm going to do is I'm going to go ahead and jump to the next branch. All right, and now this home screen, my home.dart file, you'll see that I've created a custom scaffold widget. And this is beneficial because if I open this up, this is going to look familiar. This is all that code that I had in there before. Now, why did I just pull this out and put it in its own file? Because every screen that I use in this app is going to reuse this scaffold. So if I want to make a change to it, rather than editing 500 different files, it's easier to just have that custom scaffold in its own file. And so that's why we did that refactor there. So it's if you look at the top of the home, you'll see that I'm now importing that custom scaffold. That's what this widget's custom scaffold.dart file is. And if we want to change the app bar color, if we want to do anything, you can change it in one place, and now it's changed across the entire app. So literally what we should have if I refresh is the exact same thing that we did before, but we've pulled out the code that we're going to reuse and put it into its own file. So now I promised you to show you how routing works. So we're going to go ahead and do that now. So if we go to the settings.dart screen, first off, you'll see that I've got another custom scaffold there. And I've created just a very basic screen. We're not going to actually create any settings in here for the sake of brevity. Basically, it just returns a text widget that says, if this app had any settings, it would go here. So I'll just quickly demo that. So,
Lance, did you have a question?
Yeah, just why did you have it in the import in home.dart instead of app.dart? So it's only being used there?
Correct.
Okay.
Yes.
And it doesn't inherit from
correct.
home? Okay.
You want to do your imports at the most level of specificity that you need them. So I didn't want to go up the chain because I was using it in a specific area. So if we go here and we get the settings, boom. Now we're on a completely different screen. We're on the settings screen. So if we actually had settings, there they would be. And we're reusing that custom scaffolding across both screens. So if we come down here to the routing in app.dart, you'll notice that we have a new named parameter here. On generate routes, we're passing it this route method down here. So the routes method returns a route, and basically every time you push a named route, it's going to go into the switch statement, and if I push the base route, it takes me to the home screen. If I press the settings route, it takes me to the settings screen. You can see that it's returning a screen route, the name of the route, and that widget is the name of the screen that we just created. So home and settings. And then I created a default just because Flutter always puts you that default from switch statements that returns the home widget. And then down here, the screen route, because is another custom method that I created, and this is just the basic Flutter scaffolding for creating a route. So not the sexiest routing tool, but it gets the job done, and I've not had any issues with it so far for the most part.
How does it scale? I mean, a case statement for a large site for routing?
So what you would do is, because every route has its own individual name, you can actually put that use like a variable at the end of it and then redirect accordingly. It's not perfect, and there are higher end routing solutions available for Flutter, and I'll show you like where you would find those. But there's plugins and things to help with this. This is a very small app, so it's a very small example. But just like I think React, you have to pull in like React Router, if I remember correctly. There's something similar for Flutter.
Something like Kroger's would.
Yeah. No. You're not going to create like this ongoing for every single screen. No. There's better routing solutions out there. So this is just but you'd have to do an import for that. Okay, so moving on. This is looking pretty boring. It'd be nice if it looked more Star Wars-ish. So we're going to go ahead and go into the next thing. We're going to go ahead and add a background here. And perfect, we've got this starry background. So how do we do that? Well, the first thing is we have to specify where our image is and locate the image in the assets folder. So up here in the assets folder, I put this background image. So that's where that lives. And then the good old pubspec.yaml file that I promised earlier, pardon me, has, look for it here, we specify the assets folder there. So anything that sits in the assets folder will be imported as an asset. You actually have to specify that because the assets folder isn't special. You could have it like my awesome assets and it would still work the same way. You just have to specify it in pubspec.yaml. And then, so if we go into the home, okay, box decoration and the decoration image are custom widgets within Flutter. Again, I went shopping for that. And this box fit that cover basically is just telling it to stretch the image to fill the whole width of the screen. And then, so really simple. Few lines of code, add the background image. So next we need to add some input text boxes. So we're going to go ahead and do that. Please clean the repository tree before. Did I change something?
Looks like it.
Oh.
Get reset hard. Gotta be so smart about doing this. There we go. Perfect. Let's save. All right, cool. Okay, so the next thing we're going to do is we're going to add a place that we can input our text because we need to be able to translate our text. And so essentially, we've broken down the UI items into their own widgets to keep things clean. So if we go back here to the home.dart file, here we go. So child UI items, we're going to put all of our UI items into this custom widget. And inside of that, I've got a column because we're going to make one long column of items. And then inside of that, we're going to put an input text box, which is a custom widget I created. The expanded widget basically just says, fill up as much space as you possibly can. That chime means that the build is completed. Thank you. And then you'll see this flex. Anyone who's used Flexbox, this is exactly what it looks like. Allows you to specify how much space you want it to take up. And then the container, like I said, that's like a div. Our box decoration is what's going to give it a pretty border. And then we specify the input text field, which is exactly what it sounds like here. So basically what that gives us is this area right here where I can type in and put in some text that we're going to translate later on. So again, we can specify the text style. This is all fairly self-explanatory if you look at the code. And that's the beauty of having these named parameters, is that it makes a lot of sense if you look at it. And of course, all of that is the text field widget is the parent widget there. So, one thing I do want to point out is the hint text here versus the hint style. The text is like just the text that you put in there, and then you can specify a different color for the hint text versus what the user actually types in. Again, basic CSS stuff. A lot of the cues for this styling came from the world of CSS. It's pretty straightforward. So now that we've got an input text row, it would be nice to have an output text row. So let's go ahead and do that. Output text. Cool. And so that's what that looks like. In here, the output goes. And it looks very similar to the input text field. Again, we've got an output text box here. And again, it's basically the same thing all over again. We specified our color, we specified our borders, and we've got several nested widgets here that all eventually go into that expanded widget. And because we specified a flex of 6 on both of those, which seems like an odd number, but you'll understand why in a little bit, they're both taking up 50% of the screen. Okay, so now we need another row in there that contains a button that people can click to actually translate the text. Ideally, it would be nice to be able to have translated on the fly while they type. The API has a limit of 25 hits per day on the free tier, so we're not going to do that because that would kill our rate limit very quickly. So let's go ahead and switch over to branch number 10 here. And I have like 9 minutes, guys. Oh my god, I'm so sorry.
You're fine. You're fine. That's all. You're good.
All right, if you guys have to leave, I'm not going to be offended, okay? So let's go ahead and switch over here to this. And basically what we've added is a fun little picture of Yoda and a big translate button. And now the app UI is more or less complete. So looking at that, that is our final UI item. And if we come up here to our column, you'll notice that in our UI items column, we've got the input text box, the translate row, and the output text box. So if we come down here to the output text box, again, looks very similar before. We've got that expanded, so that gives us a certain amount of space that we're using. We put it in a div, and then we've got, oh, that's our output. We've got our padding, and then we've got our row because we're putting 2 items side by side. And then we've got the Yoda and the translate button. So if we come down here to the Yoda, I'm just loading an image asset, the Yoda.png. And translate button, again, I'm just loading the translate.png asset. All right, so the one thing that you probably notice is the problem is that if we go to type, it squishes everything down. That's a bad plan. So we're just going to go ahead and fix that real quick. And so let's go ahead to the next branch. And the way that we're going to solve that is if we go to the custom scaffold, and there is a item in here, resize to avoid bottom padding. We're just going to set that to false. And basically what that does is it says, if the screen resizes for something, don't resize the UI elements. That'd be bad if you were like rotating the phone, but we've got this locked to portrait mode, so it shouldn't be a problem. All right. So now we get to state and state management. Oh goody, y'all are gonna love this. So we're going to take a brief break here from the live coding for me to introduce the block pattern. So let me come back over here to my slides. Context. I should have introduced that earlier. So is everyone familiar with event bubbling in JavaScript? Where you start and it just kind of comes up. Context is the same thing. So remember when you saw that context inside the build method? All it's saying is where are you at on the widget tree. So remember, you know how everything's been like a nested widget so far? So we've got the app widget, and then we've got the material app, and then it just keeps going down and down and down. All context is it's saying where at on this widget tree does this widget live? Then certain things will need to know that, like when you're doing the navigator pushes and things like that. Where at on this widget tree am I currently living? That's all context is. And it's very similar, like I said, to event bubbling in JavaScript. So I would go into more detail, but we're running short on time. So the block pattern. As I said before, Flutter is not opinionated on state management. And there are several different state management options out there. You can use a stateful widget and let the widgets manage their own state. You can use a data where actually is a version of Redux available for Flutter. So if you really want to use Redux, you can do that. What Google actually recommends is the block pattern. And so essentially, the way the block pattern works is at the very bottom, you have your providers. So if your app has an internal database, that's going to be a database provider. If it needs to make an API call, you've got a network provider for that API call. Whatever is reaching outside, you've got a provider. All those providers feed into one single repository. So that repository becomes your single source of truth. That repository holds all the data. So I know some of you React people will love the phrase single source of truth. Your repository is your single source of truth for all data. Everything eventually comes back to that repository. However, the thing that connects to the repository is not your widgets, because that would require a stateful widget to do that. Instead, you've got what's called a block. And block is an acronym. It stands for Business Logic Component. And our app today is only going to have one block in it, but you can actually have multiple blocks. And then your actual widgets communicate with the block. So if I need to make an API call, I'm going to say, hey block, I need to make an API call. The block makes the call to the repository. The repository gets the data from the network provider, puts that data inside of a model, feeds that back to the block feeds it to the UI screen. Sounds convoluted. It actually works pretty well in practice. And like I said, you can have multiple blocks, and the benefit to that is you can actually control what parts of your app have control of what parts of state. So not all state is available in every widget in the app. If you separate it into separate blocks and provide different providers, you can control and prevent certain parts of your app from having access to other things. And that's nice because it's kind of the concept of least privilege and prevents things from getting overly screwed up. The other thing you need to understand is streams, and we're going to talk a little bit about that. Streams are kind of like the observer pattern. Is anyone familiar with streams in here? Okay. Basically, a stream is like a garbage disposal. So you've got your user input, which is lunch, and you dump it into a sink, and that's literally what it's called, is a sink. And then you've got a stream transformer, which is like the garbage disposal, and then you've got the stream output, which essentially is now garbage. Yay. Streams are a way of taking ongoing flows of data and passing it straight through. So if you have like someone typing in a bunch of data, you've got that stream there that collects that data. Now for our app today, we don't actually need a stream transformer. So my app is probably going to be more like a toilet. Poop goes into the sink, poop goes out of the sink, it's the same poop. Okay. Yeah, we're not ready for questions yet. Moving on, we're going to create our block. And so I've created a blocks folder inside my source folder. And I've got two files in here, the block and provider. The block is empty right now because we're not putting anything into it. Provider is a special file that we need to create that passes the block to the widget that needs it. So remember how I said context is where the widget's sitting on the tree? The block sits at the very, very, very top of the widget tree. And then, thanks to context and the provider, we're able to give that block to the widget that needs it. And you'll see how that works in code briefly. I'm not going to take the time to explain the provider code because it's long and not really long, but it's a little bit left field, and I feel like I'm losing some of you already. So just know that you need this provider code in here, and it's kind of boilerplate, and you're going to use it for every block that you create. And this is look janky? Yes. And you can actually get some block plugins from Flutter that will make this a little bit better. So we're going to go ahead and set up our block and create our first stream. So let's go ahead and jump to that. Okay, so the first thing you'll notice here is an import for something called RxStart. Those of you who are Angular developers are probably familiar with RxJS. Rx stands for reactive. RxStart is basically just RxJS. And so we're going to go down here to our pubspec.yaml, and this is where our first dependency comes in. And it is, where is it? There we go. So there's our first dependency. This is where you put all of the external packages you can get. And if you go to pub.dev, this is where you find all the packages that you can import to Dart. So like this URL launcher is a really popular one. And you would literally just include the URL launcher in your postspec.yaml, and then you can import it just using this import statement. So instead of like npm install or composer install, that's how you handle bringing in dependencies in Flutter. All right, so coming over here, we're using the RxDart library, and inside of that, we're going to use a behavior subject. And that behavior subject is going to accept our user input. And then we've got a couple of getters here. One is for the stream itself, and the other one is for the sink. The sink is where the user input will go, and then it'll live in the stream. And then right now I've created a translate message, and it just does nothing but print to the console at this particular moment. And then we've got a dispose method because Dart really wants strings to be closed at the end of it. So if we come back over here to so next thing we need to do is actually connect that block. So we're going to go ahead and jump over to the next slide. And to connect that block, we're going to come over here to our home.dart file. And you've got the import statement for the block at the top there. And then to get the block, final, by the way, is like constant JavaScript. It means that it can't change. I forgot to mention that. That provider class that we created earlier, we're just saying the block equals provider of context. And what that does is it gets the block from wherever it sits at the very top. Basically, all that statement does is take that block from the very top of our widget tree down to whatever widget it is so we can access it. And that allows us to have that persistent state management going on. And so now we can use that block in a couple of areas. So I think that's in this snapshot. Input text field. Yeah, here we go. So in the input text field, we've got onChanged. Put whatever data is put into the field into the user input sink. So if I come over here to the block, there is that user input sink that I created. So literally it just dumps whatever we need into that stream there, and we can continue processing it if need be. So, and then the translate button just connects to this block.translate method. So that translate method is down here, and we just have a gesture detector, another widget. And when it's tapped, or when that translate button is tapped, it translates it. We are getting there, ladies and gentlemen. So the next thing we need to do is add a model, and that's going to be the model for the API response. So one of my life philosophies is to always ping everything in Postman before I use it, just to see what we're going to get back, because you never trust the documentation. And Postman is giving us nothing. Perfect.
So that unchanged event happens every time you type a single keystroke?
So what?
The unchanged happens every keystroke?
Absolutely. Yes. Do I just not have internet? Is that the problem is? No? All right. I don't know why the API call failed. That could make this a very, very... Great. Okay. Well, this could be a very interesting presentation. Anyway, if it would have come back, we would have seen the model that we need to create. So we're going to jump over to that. And basically what I created is it sends back three things: a translation string, a text string, and the string that's translated. And this, I've created a custom constructor here that then takes that JSON that's parsed and actually creates the model for us. All right, and yeah, I generally ignore the documentation because it's usually wrong. So at this point, we need an API provider. So we're going to jump to that. That's the bottom of the block pattern that we've got here. And I just jumped a branch ahead because I'm hurrying. This was not as brilliant of an idea as I thought it would be.
I think you beat yourself up.
Yeah. 16 API provider. Cool. All right, So I've got the new resources folder here, and inside that I put the API folder. And basically I've just written some code here that connects to the API, and then that will then return that JSON. So we've got the JSON to code most of that here. That's going to return it back to the model via the repository. So if I come up here to the repository, I've created my repository.dart file. So the block is going to call this repository file, and it's going to call this call API method that I created. It'll instantiate the API provider. It'll call the API provider of whatever text I want to translate, and then we create a translation model from the JSON that's responded back. All right. Oh, sweet, last page. So we've written a lot of code. Now would be a good chance to see if anything is working. And I'll be as excited as you are if it does, given the fact that Postman bombed out on me. So, yeah. So let's go ahead and run this. And a couple changes I made at this step in the block.dart file is you can see we're going to get back a translation model when we call the repository API. This is an asynchronous function, so we're going to await for a response before we do anything. And then rather than doing anything in the app, we're just going to print it out to the console. So let's hope this works. A little bit worried that Postman bugged out on me. I'm wondering if the Rapid API went down, which would be perfect timing because I tested it half an hour before I came here. So let's go ahead, and this is a test. Hit that translate button. And yeah, Rapid API is not working. Well, this just got a little bit worse. Oh well. So assuming that the API would have actually returned something to us, which I promise it did, we would now need to create an output stream to put that input. So if we move on to the next dependency here, we've added a couple streams. So we've got our translation output. So after we hit the translate button, we would call the API, and then right here, we would put the translated text inside of the sink. And eventually, we can create a, let's see if I did it in this step or not. We can create what's called a stream transformer that is going to listen. Here we are. Yeah, no, I don't have them there yet, so let's go ahead and jump to the next one. All right, here we go. So we got what's called a stream builder, and the stream listens to the stream builder listens to the block translation output stream that we created, and then it basically waits for something to happen. So if we don't have any data in it, it just returns text that says, "In here the output goes." Otherwise, it returns the output text with the actual data that we receive back from the stream. So if the API was working, we would, let's go ahead and hot restart it. And the API is just not working. Really not getting a response, so sorry guys. All right, and then the last thing we can do is create a loading indicator. I'm not going to go into that. Basically, what you all came here for was to see the website of this. So I'm just going to go ahead and go back to master. Yeah, of course. And let's go back to master. So you've seen it running on the Android emulator all night. We could put it on an iOS emulator. I'm not going to waste the time to do that because you know it works. But the other thing that I can do is compile to web. So if I do flutter run -device Chrome, it's going to take a couple minutes here, but it's actually going to compile this into a web page. So yes, go ahead.
So I was coming while it's compiling up the web page there. How would something like that get hosted? If you compile it like as a web page.
Like any other flat file.
Okay.
Yeah. All right, cool. So there we go. Now, obviously, there's things we can do. We can get the screen width, and we can do things to adjust, adjust the layout for wider screens. But here it is on the web page, and we hit the translate button. We get the spinning circle. Oh, it worked! The API lives! Hallelujah! Thank you, Rapid API, for not making me look like a total idiot. Put a name on there. Yeah. API, guys. But yeah, so this is running in Chrome. So the point is that I want you to take away from this. If you take the time to learn the Flutter framework, which is fairly straightforward, if you implement the state management solution, what I just showed you, as confusing as it is, it's what Google recommends, but there are other state management options out there. Flutter itself doesn't really care about your state management. You can write code that you write it once and it can compile everywhere. The web portion is in beta right now. So they don't recommend using it for production at the moment. We're expecting it to come out of beta early next year. And the great thing about this is you can write web applications, you can write app applications, and as you can see, it all works in the same place. So at this point, I know some of you are probably running over your time, so you're welcome to leave, and I'm not going to be offended. But what questions do you have for me? I know I threw a lot. Yes?
So for mobile development, how easy it is to access the camera and memory?
Most of those things are actually going to be done through the plugins. So if you go to pub.dev, like I mentioned earlier, let me just look at the camera here. Here we are. There is a plugin for the camera right there. And you would basically import that plugin, and there's, in many cases, multiple plugins that do things like this. It's kind of like more WordPress. You know, that's a dirty word in the development community. But there's multiple plugins that will frequently do the same thing. So I would use this plugin for the camera, and then whoever wrote that has already written the native code to access that, and then you just use that abstraction provided by the plugin to access the camera in the Flutter widget.
And also, how easy is it to implement compiled C code? If I'm running an Android application, I can call currently now I can call C code. So if I have something in OpenCV, I can call that and use that in the library. How easy is it to add that to Flutter?
Haven't done it, but that's what the plugin architecture is for. So you would have to write your own plugin to do that. So Flutter would treat it like a plugin, but you would write your own C code, and then you would write a plugin that bridges between your C code and the Flutter framework. And that's what this architecture is for. I've not done it, so I don't know what else is involved in it, but you can pretty much make anything you want work through the plugin architecture.
Oh, that's pretty cool.
Yeah, for sure. What else? What other questions? Feel free to beat me up with state management, because I know that part was confusing. Yes?
What is the repo that you're going through, using right now, that you just showed?
This website?
Yeah. Not PubDev, but your presentation.
Oh, I put it in the Slack channel, and I also put it in. I put it in the meetup as well. But actually, you know what? I bet if I go to my GitHub, I think I'm logged in as me at my work account. I'm not logged in as anything. Perfect. Well, you beat hackers to steal my password. Yeah, so this is the Yoda Translator in all of the 10,000 branches that I created. And it's got an overview of the app. All of the slides are at the bottom here. And I think I just clicked on it by accident. Yeah. So it's github.com/MatthewJones517 and then /Yoda_translator. What else? What other questions?
Before getting off that topic of the repo, he did a really great job, because I was following along in your repo on GitHub. He did a very good job of breaking everything out into the the slides within features within the repository. So within GitHub, there's a drop-down menu, and you can see them broken out, like 1, 2, 3, 4, 5. So good job.
Oh, thank you.
It's really great that you broke it out that way. So if you get to the repository, it's like, this doesn't look like there's much going on, and that's because you're on the root. You click the drop-down menu and look through all the stages and see what on.
For sure. Thank you. Yes.
Yeah, so the pub.dev site, is that just for Flutter things, or is that for Dart packages? How is
I believe it's Flutter specific.
Flutter specific?
I could be wrong.
I think it says Dart.
Yeah, no, it does. It says Dart packages, so it's Dart.
Yeah.
Most of them are for the Flutter framework, so their tag is Flutter, but I think that there's Dart stuff in there as well.
Yeah, yeah. So that was my next question, is like, is Dart used for, it kind of seems as if maybe Flutter is one of the biggest Dart projects out there perhaps, and maybe that's where a lot of the Dart attention is going.
Dart can also be a JavaScript replacement. So if you're familiar with TypeScript, you know that, or CoffeeScript, Dart is very much in that vein. So you can actually write like just a regular, and that's part of why you can compile the web so easily, because Dart was essentially designed at the beginning to compile onto JavaScript. So you just write your Dart code, compile it out, and you can actually deploy Dart in web that way. For sure. Yeah.
Just out of curiosity, I've never looked at Dart before, but the way it's structured is really interesting. Could you go back to where you actually did that API call?
Yeah.
Because it looked like it was a very simple block of code to make that actually work.
So the API provider?
This is the API provider. That's something built into Flutter. Or is that?
No, that's the custom class that I wrote.
Gotcha. Okay.
So I made my own API provider. So like the DNL app uses 3 different APIs. We've got our Polaris API that connects, which is what is our catalog and stuff based off of. We've got our what's called the events API, which is what our events are connected to.
Okay.
And then we've got our own internal API that I wrote just to serve up other data to the app. Each of those APIs has their own provider that I wrote. That's because they have specific ways that they can be called. So basically, literally all I did here is I created a variable for the root, and then I built out the endpoint here and just used the encode full so that it takes whatever text and makes it URL friendly. And then the magic here is actually in this, so let me back up a second. This URI.encode full is part of the Dart convert package that I imported at the top.
Okay.
And then the second thing is this http.dart. That's an internal package with Dart that allows you to make these actual web calls. So client is part of the HTTP package, and then it's just a matter of setting up the headers, and then I'm making a post request. So client.post, and I pass in the URL and the headers. That passes back to raw JSON, and then Dart convert has that JSON.decode. So whatever was in this response gets decoded by the JSON, put it in the return value, and then I've got basically a map, which is like an associative array for PHP folks, that I then just dump into the model.
Okay.
Sorry, I know I kind of sped past that because I was getting worried when I saw that it was past 7 o'clock. I didn't want to be the annoying guy that completely ran over. But yeah, excellent question. What else?
So the artifact that Dart creates are JavaScript files, and they're deployed via this Electron framework.
So yes and no. If I compile to the web, it puts out JavaScript files.
Okay.
If I compile to iOS or Android, it puts out native code.
Does it use the native widgets?
No, they're vendors.
So how is it? What rendering engine is it using?
They have their, basically it has its own rendering engine. So basically it pre-compiles it.
Inside the shell,
Yes.
they deploy the app code.
Yes. So it pre-renders it, and then it goes through its own rendering
Compiles
engine
it,
first,
and
and
then,
yeah.
then
Yes.
renders that compiled
Correct.
file.
So along those lines, I think a lot of these frameworks that will try to compile to multiple mobile platforms, they'll use like a web view inside of, and that's like Ionic and some of these other ones.
Completely different.
So
It's
this
not a
isn't
web
doing
view.
that.
It's
Okay.
not a web view at all. It is absolutely native code, running natively. It's not, because I've used Ionic and Adobe, what is there?
Cordova?
Yeah, Cordova, I've used.
Focus?
Yeah, it's all the same.
Yes,
stuff.
yes, yes.
This isn't that. This actually compiles native code.
Okay.
And you'd have to go through the normal processes of going to the App Store, submitting as you normally would for.
Yeah, so that's actually, there's two different commands that you have to run. There's like Flutter build APK or something like that, and then Flutter build iOS, I think. And then from there, you actually have to take the compiled files and like, one of them you have to open in Xcode and then submit that way. And then the other one, you actually just have to find the APK and then manually submit to the Google Store. But you have to go through the submission process the same way, for sure. Yes?
How's the debugging support in
Amazing, oh my God, thank you for asking. If there's one thing that I love, it's the debugger. So I should point out that you have your choice. You can either use Visual Studio Code or you can use Android Studio. I use VS Code just because I prefer it. But I'll just go ahead and fire up the debugger here. And while that's launching, because it's going to take a few minutes since I've got a bunch of stuff open, you can just like set breakpoints by doing a normal thing along the edge here of VS Code. You can inspect and cite variables. Everything you would expect the VS Code debugger to do, you can do. Plus, there's more. I'll show it to you as soon as it opens. But there's something called Dart DevTools, and it allows you to inspect the widget tree using Chrome. So it'll open up a Chrome window, and then it'll show all the widgets, and then I can do performance profiling there. I can view. I can see exactly where in the widget tree anything sits. I can see how things are laid out. So if I got a funky layout problem, I can see how that's working. It's amazing. So it's
I tried to get your GitHub, but it did.
Yoda_Translator.
Underscore.
Yeah.
and that works for all of the platforms, or can you only debug in the web plugin?
It works for the Android and the iOS. I've not tried running the debugger on Chrome. So I don't
Oh, really? Okay, so, but it like natively runs in AE or something like that?
Yeah. So let's see, I think we're running. Yes. So let me go ahead and open up Dark DevTools here. Updating Dark DevTools. Oh, DevTools is currently active. Okay, I might use that and set up to automatically. Where's the DevTools? Let's just close Chrome altogether. Try to watch it. DevTools is currently. There we go. So these are the Dart DevTools. So let me just pull it over here because it'll be easier if we've got it side by side with the app here. So yes, sounds good. So if I want to do like a debug pane, I can see how all of the items are laid out there, which is really nice if you've ever had a layout issue. I've got some performance profile. If I want to look at the different widgets, I can come down here. If I want to go into select widget mode, I can actually click on a widget, and then it'll take me directly to that so I can see exactly what's in there, and I can go up the tree and see what's happening. The debug tools are so powerful, and it's one of the things that I really love about it.
Does it support remote debugging, like on a device itself?
Yes. Yes, actually, everything you just saw in the emulator, I could plug my phone in, and it would have done directly on the device. When I was writing the DML app, I had a stack of phones on my desk, and I was just testing it on the phones, and I would be plugging one phone after another. And actually, you can plug in multiple phones at once. So you can have like an iPhone, a couple of Android phones there, an iPad, and when you hit that Shift R, it just updates what you're writing on all the screens simultaneously.
And you can set a breakpoint that you can hit by using your phone.
Yes,
Okay, sweet.
it's amazing.
Did you say at the beginning that the Dayton Metro app,
Yeah, that's my app.
that's your app?
Yep.
That's written in Flutter?
Yeah, completely written in Flutter. Yes, sir. What else?
There's a question brewing over here.
If I don't know, I'll just say I don't know, so don't feel bad about asking any questions.
Have you played at all with publishing it to like a desktop app?
Not yet. That's still in alpha right now.
Right.
So-
I'm just wondering how it compared to Electron, because I could see this as being an awesome, because it actually compiles down to machine code,
Mhm.
like ARM code. I can see this being a way better option than Electron.
Oh yeah, for sure. Well, you're going to get a performance boost over Electron because Electron is. I hate the stereotype that all Electron apps are slow, but they're not going to be as fast as a native app, just because you've got all that overhead. So for sure.
You use Visual Studio Code quite a bit.
So what?
You use Visual Studio Code quite a bit.
Yeah, that's what I write in all day. Yep. Yeah, go ahead.
So I'm assuming you tested on the new weird screens. It handles that all right, or do you have to do any specific stuff to handle like an iPhone X? Or
So there was a widget that I showed very briefly, and then I spun by it.
yeah, so like my phone, like half the apps I use don't handle the notch well, right?
They do the
And so you have to
scaffold.
do specific sort of stuff to deal with that.
App text.
It was safe area or something like that?
Yeah, I'm looking for the safe area widget. Let's just do this. Here we are. So here's an example. This safe area widget, basically what it does is Flutter's smart enough to know what phone it's running on. So by using the safe area widget and putting everything inside the safe area widget, it says, "Oh, you got a notch. I'll make sure your content doesn't go inside the notch."
It's really nice.
Yeah. Yeah, whatever problem you have, the engineers at Google have already thought it through, which is pretty sweet.
Does it feel like there's some process of approval with the library, the widget library? Is it possible some nefarious content?
What do you mean?
You're suggesting going to the widget library, looking for your solution, very WordPress-y, and part of WordPress prides themselves on is that they do a lot of vetting of the content that's in there. So, do you feel that you do a good job as far as?
A lot of it's written by Google themselves.
That's what I was
So,
expecting to say.
yeah, a
expecting to say
huge
that.
chunk of it is written by Google themselves. And the stuff that's not is open source. And it's like anything. Would you just install a random NPM library that was written by some dude that you've never heard of before and had maybe a one install? I wouldn't put that in a production app. But if you're installing a plugin that's been installed by hundreds of thousands of users and is open source and is published by someone reputable like Google, then yeah, I feel comfortable putting it in my production. You just have to use the common sense that you would anywhere. Go ahead.
With what you were talking about there with that, I know with like NPM, they started adding in like security checks and stuff like that, and then you can get like alerts if you have like a package that's been found to have issues. Do you know if they have anything like that?
I don't know. I think it would be hard for them to alert you just because of the way there's no like install process. Like installing a package is literally adding that pubspec.yaml file, and then it's imported. So I don't necessarily know how Google would keep track of whether or not you're using that package. Is there a vetting process? I don't know.
Okay.
I'm assuming that there's something, but I
Yeah.
don't know. Yeah. All right. Any other questions? Yeah.
You mentioned that this was really good for getting designs that look consistent across different platforms.
Yes.
If you wanted to not do that, right? You wanted to use like iOS looking menus versus material design looking menus on Android. Is that just going to be like really going against the grain of this, or are there options for that?
No, let me. So there's a whole widget library called Cupertino, called iOS style widgets. And every major widget that's part of the iOS UI library is right here. So if you want something that looks very iOS-y, you can still use Flutter. You would just import this widget library and you use these widgets.
So how do you do the if Android, if iOS thing?
This is called, and I usually use like a ternary operator. I have that in 1.8 in the DNL app because I've got an Apple Wallet integration, and obviously I don't want to store that on the Google side.
Right.
So, I forget what it is off the top of my head, but there's just a simple coin here that says what platform am I? And I just use a ternary.
So you basically build pages for each application,
If you really want to go down that route, you can. I highly
if you want the
recommend
native field.
Right. Just wherever in the UI you would want those things to diverge, you can conditionally load the widget that corresponds to your platform.
Yeah. Yeah. All right, any other questions? Going once? Going twice? All right, well, thank you all very much. I appreciate your patience. I'm literally half an hour over my time. But
You
thank
need
you
to
so
go
much.
to your closing screen, which has got your contact information first, right?
I
You have
think
one of those in your
so.
slide?
I think I closed my slides when I was trying to get the dev tools. If you want to reach me, I'm mjones@daytonmetrolibrary.org. Yeah, no contact information. I am the worst presenter ever.
From Anonymous.
My Twitter is @MatthewJones517. I have no friends, please follow me. So you can find my Twitter. You can email me, mjones@daytonmetrolibrary.org.
Say M. Jones
Yes, mjones
at Metro,
@daytonmetrolibrary.org.
DaytonMetroLibrary.org.
Yep, that's me. Those are 2 ways to get a hold of me.
Thank you, sir.
Thank you.